Mars looks dead, but it wasn't always. That's the part nobody really stops to think about. We see the photos, the rust-colored desert, the barren plains, the ancient craters filled with nothing but dust and silence. And we assume that's just what Mars is, a dead rock. Always was, always will be. But Mars had rivers. It had lakes. It may have had oceans covering almost half its surface. And somewhere along the way, something went terribly, catastrophically wrong. Something killed it. And the real reason Mars looks the way it does today is one of the most haunting stories in our entire solar system. We've been sending rovers, landers, and orbiters to Mars for decades. Every mission reveals something new. And piece by piece, scientists have been assembling the true story of what happened to our neighboring planet. A story about a world that had everything it needed for life and lost it all. Understanding what killed Mars isn't just a history lesson, it's a warning. Because the forces that destroyed Mars are forces that exist right here, on Earth, right now. And knowing what happened, there might be one of the most important things we ever learn. I've spent years tracking the science coming out of Mars missions. From the early Pathfinder days, all the way through Perseverance and the Maven orbiter. And the picture those missions paint together is far more dramatic than most people realize. This isn't a story about a planet that was always cold and empty. This is a story about a world that died. Here's what we're covering. First, what Mars actually looked like billions of years ago, because it was nothing like today. Second, the specific chain of events that destroyed it. And third, what this tells us about Earth and what we should be paying attention to right now. Let's go back, way back. About 4 billion years ago, Mars in its early days was a world with a thick atmosphere, not quite like Earth's, heavier in carbon dioxide, thinner in oxygen, but substantial, enough to trap heat from the sun, enough to keep temperatures above freezing across much of the planet's surface. Enough to allow liquid water to exist, not just for a moment, but for potentially hundreds of millions of years. We know this because of the evidence carved into the Martian landscape. Valley networks that look exactly like river systems on Earth, carved by flowing water over long periods of time. Ancient shorelines where scientists believe a vast northern ocean once sat. Minerals that only form in the presence of liquid water. Clays, carbonates, sulfates spread across the surface in exactly the pattern you'd expect if water had been present for a geologically significant amount of time. Mars was wet, Mars was warm, and if the conditions were right for liquid water to persist for that long, they may well have been right for something else too. But then it all ended. And it ended in a way that, once you understand it, you cannot stop thinking about. Here's the key. Earth has a magnetic field. You've probably learned about it. The invisible shield generated by the movement of molten iron in our planet's outer core, wrapping around the Earth and deflecting the constant stream of charged particles pouring out of the sun. That stream is called the solar wind, and without a magnetic field to stop it, it would strip away our atmosphere over time. Mars had a magnetic field too. Ancient magnetized rocks on the Martian surface prove it. Those rocks locked in the direction of the field when they solidified billions of years ago. The same way a compass needle locks in on Earth's field today. Mars had its shield. And then, somewhere around 4 billion years ago, it lost it. The Martian core cooled. Mars is smaller than Earth, about half the diameter, and smaller planets lose their internal heat faster. As the core cooled and solidified, the churning movement that generates a magnetic field slowed down and eventually stopped. The dynamo switched off, and the solar wind got to work. Without a magnetic field to deflect it, the solar wind began hitting the Martian atmosphere directly. Particle by particle, molecule by molecule, it began stripping gas away from the top of the atmosphere and flinging it out into space. It didn't happen overnight. It took millions of years, but it was relentless, and Mars had no way to stop it. NASA's MAVEN orbiter, a spacecraft specifically designed to study this process, measured it happening in real time. Right now, today, Mars is still losing atmosphere to the solar wind, about 100 grams of atmosphere per second, escaping into space. That number sounds small, but multiply it across millions of years, and you have a complete planetary catastrophe. As the atmosphere thinned, the greenhouse effect weakened, temperatures dropped, liquid water became unstable on the surface, rivers froze, lakes evaporated or turned to ice, oceans, if they existed, gradually disappeared, some freezing at the poles, some being lost to space as water vapor broke apart under ultraviolet radiation with nothing to block it anymore. And Mars became what we see today. A frozen desert with an atmosphere so thin that the air pressure on the surface is less than 1% of what you'd feel standing on Earth at sea level. If you were standing on Mars without a spacesuit, your blood would boil. Not from heat, from the near total absence of pressure. The atmosphere is simply not there anymore. Now, I want to pause here and ask you something. When you picture Mars in your head right now, what do you see? The red desert? The rovers? Drop it in the comments, because I'm genuinely curious whether this changes your mental image of the planet. Because here's the part that gets really interesting and a little uncomfortable. Mars didn't just lose its atmosphere randomly. It lost it because of a specific structural failure, the collapse of its magnetic field, which happened because the planet was too small to keep. Its core hot enough to keep the dynamo running long. Enough. Earth's core is still churning. Our magnetic field is still active. The solar wind is still out there, hitting us every second of every day. And our magnetic field is still deflecting most of it, keeping our atmosphere intact, keeping our water liquid, keeping the surface of this planet livable. But here's the thing, Earth's core is cooling too, slowly, over billions of years, and our magnetic field has actually weakened by about 9% over the last 170 years alone. Scientists debate what that means long-term. Most believe our field will persist for billions of years more, but Mars is proof that it can fail, that it has failed, that when it does, the consequences are total and irreversible. There's also another angle to this that most videos don't talk about. Mars didn't just lose its magnetic field. It may have also been hit hard enough, early enough, to fundamentally change its geological destiny. Evidence suggests the entire northern hemisphere of Mars was reshaped by a colossal impact early in the solar system's history. An impact that may have disrupted the planet's internal dynamics, accelerating the cooling of the core, speeding up the timeline of the magnetic field's collapse. So the death of Mars might have been triggered by violence, a collision so massive it essentially determined everything that came after. The rivers, the oceans, the atmosphere that followed were all living on borrowed time from the moment that impact happened. And we'll never know for certain if anything was alive in those rivers and lakes before the clock ran out. That's the real reason Mars looks dead. Not because it was always cold and barren, but because it was warm and wet, and then its magnetic shield failed, and the solar wind took everything, the atmosphere, the water, the warmth, and scattered it into space. And what's left is the skeleton of a world that could have been extraordinary. So let's land this. Mars once had a thick atmosphere and liquid water on its surface. Possibly for hundreds of millions of years, its magnetic field collapsed as its small core cooled, leaving the atmosphere completely exposed to the solar wind. Over millions of years, The solar wind stripped that atmosphere away, and without it, all surface water disappeared. What remains is a frozen, irradiated desert. Not because Mars was always this way, but because it lost the one thing protecting it. And Earth has that same protection, right now, which is either deeply reassuring or a reminder of exactly how precious and precarious this situation is. If this video made you see Mars differently, hit that like button. It genuinely helps more people find content like this. Subscribe, because we dig into the real science behind the universe's biggest stories. Not the surface version, the real version. And next time, we're looking at something that has scientists genuinely baffled right now. A signal from deep space that repeats on a precise schedule and nobody can fully explain. You'll want to be there for that one. Thanks for watching. Mars was once alive with possibility, and somewhere in that story, there's a lesson that belongs to all of us.